In the space of science and gigantic privileged insights into the topic of existence prior to the significant impact, blended conversations and intrigued characters have persisted for quite a while. This Goliath's request tests more than just our methods. It could separate the universe from itself. It challenges the very limits of human understanding. Standing at the edge of existence, studying the enormous shadows, and contemplating what was there before our universe was imagined, we turn to the event of the Big Bang, which marked the beginning of history, the universe, and what we are. Regardless, we know that there was a moment before this. Sooner or later, there might have been a condition of nothingness, a calm before the bombastic explosion. Getting organized and assuming that this is legitimate, was it truly nothing? Or perhaps something significantly more dramatic existed long before time? Just like that, we skip ahead to the science of this question, which takes us to the place where the beginning of the universe was first theorized. This question puts our mindfulness and physicists to the test. Brian Cox, well known for his dedication to the miracles of the universe, indicates that shocking possibilities existed prior to the Big Bang. He inspires us to reevaluate our thinking about the real world and existence. In this analysis, we will examine the science, speculation, and fascinating secrets that might help us understand what existed before everything. We will investigate ideas such as quantum enlightenment, dark energy, and even the possibility of multiple universes. These theories might feel restrictive, but they might also open up new ways of understanding our place in the grand design of the universe. We will delve deep into a world that goes beyond science and imagination, where the shadows continue to circle, leaving scientists astounded. Even when challenged, we must at times examine the world prior to the Big Bang and consider why these hypotheses pose a threat to everything we thought we knew. To appreciate what could have already existed, we must first understand what the Big Bang actually was. The Big Bang, as scientists describe it, refers to the event in which the universe, in an extremely hot and rapidly expanding state, set off the formation of all matter, energy, and fundamental forces. As we gaze up at the night sky, we observe evidence of this explosive beginning in galaxies spreading outward from the initial singularity. But why did this occur? Or, more intriguingly, what existed before this dense, rapid expansion? According to the cosmic inflation theory, before the Big Bang, the universe was in a state of extreme cold and emptiness, much like an enormous vacuum. However, this vacuum was not entirely empty. It contained an enormous amount of energy that controlled the speed of space's expansion. This process, called inflation, occurred so rapidly that it laid the foundation for everything that followed. In a fraction of an instant, space expanded at unbelievable rates until the inflation slowed, and its energy transformed into matter, particles, and the forces we now recognize as part of the Big Bang. But what was the nature of this energy? Where did it come from, and why did it stop? Scientists believe that this boundless expansion could have created multiple patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching infinitely, with tiny air bubbles forming across it, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that an unimaginable number of Big Bangs could have occurred, creating a boundless number of universes. Our universe may be just one of many. This tremendous, mind-bending reality challenges our ability to comprehend the entirety of existence and leads us to ask, what else is out there? The concept of nothingness before the Big Bang is theoretical, not absolute. Even if all energy and particles were removed, there would still be radiation from the universe. In truth, the universe is never truly empty. Dark matter, dark energy, quantum fields, and various forces interweave to create a cosmic framework, even at its most seemingly vacant state. Even if we imagine removing these forces, leaving behind what appears to be a dead space, the universe would still generate new forms of energy. This baffling reality suggests that true emptiness may be impossible. Space itself has inherent rules, properties, and constants that prevent it from ever being completely devoid of content. Imagine creating a region with literally nothing, no particles, no radiation, no energy. Even in such a space, quantum fields would remain, indicating that this nothingness still has properties. One such property is the concept of zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles continue to fluctuate in and out of existence, creating a ghostly resonance in what should be empty space. This phenomenon challenges our traditional assumptions about voids and suggests that, yes, even before the Big Bang, something may have existed. Analysts are still beginning to appreciate this possibility, which is one of the most astonishing theories in modern cosmology. One of the most groundbreaking hypotheses is that of unstoppable cosmic progress. If inflation could create our universe, it's possible it could continue perpetually. Brian Cox describes a vast multiverse where inflation continuously gives birth to new universes in an unimaginable, never-ending cycle. Consider each Big Bang to be a spark, igniting another universe while inflation continues to occur in different regions, creating countless additional universes. Theoretically, this process could go on forever. This concept of an infinite chain of universes leads to the intriguing idea of a fractal-like cosmos, where every new universe might generate its own Big Bang. Each universe exists as an independent, self-contained space, unaffected by others. For researchers, this hypothesis is both exciting and unsettling, as it suggests an endless multiverse with no clear beginning or end. Finally, imagine our universe as just a tiny fragment in an unimaginably vast, boundless system, constantly evolving and generating new universes. What if that were the true nature of reality? Perhaps there is no before or after, only an eternal pattern of universes forming. Our understanding of nothingness changes when we consider quantum field theory. The universe, as demonstrated by this theory, is not merely empty space with floating particles. Instead, it is a network of interconnected energy fields that define the very fabric of existence. These fields are like invisible oceans, with particles acting as waves rippling across them. Even at their lowest energy state, the so-called vacuum state, these fields are still active, allowing particles to momentarily appear and disappear, borrowing energy before returning it. This quality results in virtual particles, entities that exist briefly before vanishing, leaving behind only traces of their presence. The existence of virtual particles challenges the very possibility of true emptiness. Even if we remove all known matter and energy, the universe would still not be a true void. According to quantum field theory, even in a vacuum, fields remain dynamic, sometimes generating transient particles. This means that nothingness, as we traditionally define it, may not exist at all. Instead, fields and forces continue to persist. If dark energy was present before the Big Bang, then the pre-universe state may not have been a true void but rather a dynamic and energetic structure. This raises the question, was there ever an absolute beginning, or has existence always been in motion, transitioning from one form to another? Some theories propose that dark energy, in its primordial state, may have provided the necessary conditions for inflation to begin. In this scenario, our universe was born not from true nothingness, but from a fluctuating sea of quantum energy, where sudden surges of energy triggered the rapid expansion we call the Big Bang. If this is the case, then rather than a singular event, the birth of universes could be a recurring phenomenon, one that has happened countless times before and may continue indefinitely. The eternal universe hypothesis. One of the most radical yet compelling possibilities is the idea of an eternal universe. This challenges the conventional view that time, space, and matter began at the moment of the Big Bang. Instead, some physicists suggest that time extends infinitely in both directions, meaning our universe may have emerged from the remnants of a previous cosmos. Several models attempt to explain this concept. The cyclic universe theory, for example, suggests that the universe undergoes endless cycles of expansion and contraction. According to this model, after each universe reaches a critical size, it begins to collapse in a big crunch, eventually leading to another Big Bang. If true, our universe would not be the first, and it certainly wouldn't be the last. Another theory, the conformal cyclic cosmology, CCC, proposed by physicist Roger Penrose, suggests that the universe goes through infinitely repeating eons, where the distant future of one universe becomes the birth of the next. Penrose argues that as the universe expands and black holes evaporate over trillions of years, it approaches a nearly featureless, low-energy state that resembles the conditions before the Big Bang. In this view, the end of one universe seamlessly transitions into the birth of another. These theories suggest that rather than having a definite beginning, the universe is part of an eternal cycle. The implications are staggering. The cosmos could be much older than we ever imagined, and our existence might be just one chapter in an infinite story of creation and destruction. Quantum tunneling and the spontaneous birth of universes. Another fascinating hypothesis explores the possibility that our universe formed through a process known as quantum tunneling. In quantum mechanics, particles can spontaneously tunnel through energy barriers, appearing in places where classical physics would deem impossible. Some physicists propose that an entire universe could emerge through a similar process. If a pre-existing quantum field had enough energy fluctuations, it could have spontaneously tunneled into an expanded state, triggering inflation and forming a new universe. In this scenario, our universe could have been born from a quantum fluctuation in a larger pre-existing space, a vast, possibly eternal, quantum landscape. This idea aligns with the concept of the quantum multiverse, which suggests that multiple universes constantly emerge from quantum fluctuations in a higher dimensional space. If true, then our universe is just one of an uncountable number of parallel worlds, each with its own laws of physics and conditions. Brain cosmology, a universe born from higher dimensions. The brain cosmology theory, which comes from string theory, offers another possible answer to what existed before the Big Bang. It suggests that our universe is a three-dimensional brain floating in a higher dimensional space. According to this idea, what we perceive as the Big Bang may have been the result of two higher dimensional brands colliding. In this framework, multiple brands could exist, each representing a separate universe. These universes could occasionally interact, triggering new Big Bangs and leading to the birth of fresh cosmic structures. This concept is part of M-theory, a branch of string theory that proposes the existence of 11 dimensions. If brain cosmology is correct, then our universe did not emerge from a singularity but rather from an event in a much larger, multidimensional reality. This means that before our Big Bang, there were other universes, each following their own independent timeline. The mystery of pre-Big Bang physics. Despite these fascinating theories, one of the greatest challenges in understanding what existed before the Big Bang is the lack of direct observational evidence. The laws of physics as we know them break down at extreme conditions, making it nearly impossible to peer back beyond the cosmic horizon. However, ongoing research in quantum gravity, string theory, and observational cosmology may offer new insights. The study of the cosmic microwave background, CMB, the afterglow of the Big Bang, continues to provide clues about the early universe. Some scientists believe that faint imprints in the CMB might contain signatures of pre-Big Bang events, such as remnants of previous cosmic cycles or fluctuations from a quantum origin. Another avenue of exploration is the study of gravitational waves. If a prior universe left behind ripples in spacetime, these waves might still be detectable, offering potential evidence for a pre-Big Bang era. Conclusion: the search for ultimate origins. The question of what existed before the Big Bang remains one of the most profound mysteries in science. Whether the universe emerged from a vacuum fluctuation, a higher dimensional collision, or an eternal cycle of cosmic rebirth, the search for answers continues to push the boundaries of human knowledge. If one thing is certain, it's that our understanding of the cosmos is still in its infancy. As new discoveries in physics and cosmology unfold, we may one day unravel the true nature of existence and finally answer the question, what came before everything? Could energy from dark energy be the quiet spokesman for inflation, or even the real beginning of our universe? In examining this possibility, we face the potential of dark energy as more than just an influence on our universe but as a key that could provide access to the multiverse itself. Another theory suggests that cyclic cosmology offers an alternative to the Big Bang as the only conclusive beginning. According to this theory, the universe experiences massive cycles of birth, death, and renewal. The Big Bang did not happen just once but may be part of an eternal cycle where universes separate, develop, and then recover in another cycle. According to this model, our universe could have been reconstructed from the ashes of a previous universe. The cyclic compression and expansion imply that there was never an actual beginning but rather an eternal series of emerging universes that continually renew themselves. Cyclic cosmology raises profound questions. There is no other time like the present, as it suggests that time itself might repeat instead of proceeding linearly. If this theory is true, it could imply that what previously existed before the Big Bang was just another shattered form of the universe, bearing the foundation for our current one. This theory provides an extensive response to the question of extreme origins, proposing that the universe has no clear beginning but has always existed in some form, transcending our perceptions of existence and time. Gravitational waves are another intriguing concept that could shed light on the world prior to the Big Bang. Discovered in 2015, these waves are ripples in spacetime caused by extremely massive events, such as the collision of black holes or neutron stars. These waves can transport information over long distances about the events that produced them. Some physicists propose that gravitational waves from the period before the Big Bang might provide insight into the state of the universe before inflation began. If these waves contain remnants of past cosmic events, they could help determine whether the Big Bang was truly the beginning or if pre-existing cosmic entities shaped our universe. However, these waves might also be influenced by conditions beyond our conventional understanding. If such signals exist, they could reveal a structure beyond what we currently perceive. Just as the discovery of the Big Bang reshaped cosmology, Detecting these waves might uncover traces of a previous universe or an event that predates the Big Bang. Scientists continue to explore the deep reaches of space, examining theories that point to quantum mechanics, multiverse theories, and cosmic inflation. As our understanding of the universe expands, we must also consider how these theories might fit together to reveal the true nature of existence. In the meantime, the mystery of what came before the Big Bang continues to inspire scientific exploration. As we investigate the origins of time itself, the concept becomes increasingly difficult to comprehend. Time, as we understand it, began with the Big Bang. If time did not exist before the Big Bang, can we even speak of a before? Some theories suggest that the Big Bang may not be a clear-cut starting point. Instead, our comprehension of it may be limited by the current framework of physics. One of the most fascinating aspects of these theories is that they open the door to new laws of physics, laws that have not yet been discovered or imagined within our current understanding of the universe. If the Big Bang marked the beginning of everything we know, what governed the forces and particles that existed before it? Some researchers speculate that an underlying reality existed before the Big Bang, one that transcends time and space, where our familiar physical laws break down. This metaphysical layer could challenge everything we know about the universe while also holding answers to some of the most profound questions about existence. For example, some theories suggest that the universe's origin may not have been a singular event but rather the result of higher dimensional interactions. In string theory, the fundamental building blocks of matter are not point-like particles but one-dimensional vibrating strings. These strings might exist in higher dimensional spaces beyond our observable 3 dimensions. If this theory is correct, our universe could be just one slice of a multidimensional space, intersecting with others to form the multiverse. In this scenario, the Big Bang might represent the intersection of these dimensions, occurring as part of a continuous cycle of universe creation and destruction. Similarly, the ekpyrotic model suggests that our universe may have resulted from a collision between higher dimensional brain structures. If such collisions occurred, they could have triggered an event similar to the Big Bang, initiating a new cycle of expansion and contraction. These models provide a framework for understanding the origins of the universe without requiring a traditional singular beginning. This idea of cosmic rebirth challenges conventional wisdom and opens new possibilities for how the universe evolves. There are also intriguing philosophical and cosmological implications, questions about the nature of existence itself. If space, time, and matter have always existed in some form, does this imply an eternal, unchanging reality beyond what we can observe? Or are we part of an endless cycle of creation, destruction, and expansion? Some argue that answers to these questions may fall outside the realm of science and may require metaphysical or even spiritual inquiry. This suggests that the limits of human understanding are not just technological but also existential. In conclusion, while we may never have a complete answer to what existed before the Big Bang, the theories and concepts surrounding it provide a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to evolve, we may move closer to uncovering the true nature of time, existence, and the universe itself. Regardless of whether the answer lies in science, philosophy, or something beyond our current grasp, the mystery of what preceded the Big Bang continues to engage and motivate humanity's search for knowledge. Building upon these ideas, the search for what preceded the Big Bang leads us into deeper questions about the fundamental nature of reality. If time and space were born from the Big Bang, then what framework, if any, governed the pre-Big Bang state? Some theories suggest that quantum fluctuations in a vacuum-like state could have spontaneously given rise to the universe. In quantum mechanics, empty space is never truly empty, it is filled with energy fluctuations that momentarily create and annihilate particles. It is possible that one such fluctuation reached a critical threshold, triggering inflation and the rapid expansion that became our universe. Another possibility is that the universe was born out of a quantum tunneling event. In this scenario, the universe existed in a high-energy state and, due to quantum uncertainty, transitioned into a lower-energy state, leading to its expansion. If true, this would imply that the Big Bang was not a singular moment of creation but rather a transformation from one state of existence to another. Similarly, some cosmologists propose that black holes could be the gateways to new universes. According to this theory, the matter that falls into a black hole may be funneled into a new region of spacetime, creating a separate universe. If our universe originated in such a manner, then the Big Bang could have been the result of a black hole forming in a parent universe, suggesting that our cosmos is part of an infinite, branching multiverse. The multiverse theory itself presents an even grander perspective. If multiple universes exist, each with its own set of physical laws and constants, then our Big Bang might be just one of countless such events occurring across an infinite expanse of reality. Some models suggest that these universes may occasionally interact, leaving subtle imprints on the cosmic microwave background radiation. Scientists are actively searching for such signatures, hoping to find evidence that supports the idea of a multiverse. Additionally, the holographic principle offers a radical reinterpretation of our universe's origins. This theory suggests that our three-dimensional universe could be a projection of information encoded on a two-dimensional surface at the boundary of the cosmos. If this is true, then the Big Bang may not have been the absolute beginning but rather a shift in how information was structured in the larger reality. As we continue to explore these possibilities, we are confronted with profound philosophical and existential questions. If the universe is infinite, cyclical, or part of a vast multiverse, what does that mean for our place within it? Does the search for a single, ultimate beginning even make sense, or is existence itself an eternal process without a definite starting point? These questions push the boundaries of both science and philosophy. While physics seeks empirical answers through observation and experimentation, some aspects of the pre-Big Bang universe may remain forever beyond our reach. Yet, each discovery, whether in gravitational waves, quantum mechanics, or cosmology, brings us closer to understanding the deeper nature of reality. For now, the mystery remains. But as our knowledge expands, so too does our ability to question, explore, and imagine the vast possibilities that lie beyond the edges of the known universe.